Hello everyone, today let's solve the problem mysterious present. So this was asked in the Codeforces beta round 4 for the division 2, right? So you can just go through the question, it's easier to understand. I'll just summarize so that it will be easier for us to solve the problem, right? So let's see what the question states here. Just give me a second, 1 second. Yeah, so here Peter has n envelopes. See here, Peter has n envelopes and a card of size W into H. Peter has n envelopes and a card of size W into H. What we need to do then? We need to find the longest chain of the envelopes where each next envelope has strictly larger width and height than the previous, right? So we have to find the longest chain of the envelope where each next envelope has strictly larger width and height than the previous one. So the next envelope, what we consider, it has strictly larger width and height than the this one previous envelope, right? So just keep this in mind. So this is what we need to find, basically longest chain of envelopes, but not only the single envelope, longest chain of envelopes where each next envelope has strictly larger width and height than the previous, and the card fits into the smallest envelope of the chain. It has to be strictly smaller. Just remember this one. We have to output the, what we need to output, we have to output the maximum chain length and the indices of envelopes forming that chain, right? Starting with the smallest. So this is about the question. So now let's do one thing. Now we have understanding of the question. Let's quickly discuss the this one, input output. See here, we have 211, 222 and so output that we need to get here is one is this one, 1 and 1, right? So this is it about the input output. The same thing goes with the example 2 as well, or the input 2 as well. So this is about the question and the input output. So let's do one thing. Let's discuss the approach followed by the complexities and then let's write the code. As usual, let's discuss the approach. So here I have considered the same first example that they have given in the question, right? So this is fine. So 2 1 1 2 2. So the output that we need to get here is 1 1. So one thing I want to tell you here is we will be making use of the dynamic programming or the DP to solve this particular problem. Just keep this in mind, right? So let's go on with the, or let's move on with the step-by-step explanation here. First, what we'll do, we will filter. Let's see what we will filter. First thing we do here is we'll keep only envelopes, right? So this is not envelope first. So this is envelopes strictly larger than the card 1 into 1. Right, so we'll keep only the envelopes strictly larger than the card 1 into 1, right? Both the envelopes 2, 2 kept here, right? So this is fine. So this is how we filter, right? So this you will understand clearly when we write the code as well. So I just wanted to say this one because this is what we'll be doing, right? So the same thing will be implementing in the form of code. That's it. So we'll keep only envelopes strictly larger than the card, nothing but 1 into 1, both envelopes 2, 2 kept, right? So this is fine. We know this. So now let's move on with the sorting. Next step is we'll be sorting. What will sort? Basically we'll sort by width then height, right? In the question what they have asked, if you would have paid attention, I said that so we have to find the longest chain of the envelopes where each next envelope has strictly larger width and height than the previous envelope, right? So and the card has to fit into the smallest envelope of the chain and it has to be strictly smaller. That's what they have mentioned in the question as well, right? So we will be sorting by width then height, right? So both are equal, so order remains here, both are equal, right? So in our case both are equal, right? Accordingly with the example that we are considering the same example, this one, right? So in this case both are equal, so order remains env1 env2, envelope 1 envelope 2, right? So this is fine, I believe, easy, right? So let's move on with the third step here. So I said we'll be making use of the DP, right? So dynamic programming, right? So we'll be going with the longest increasing chain. So we have to consider the longest increasing chain itself, right? So accordingly with the criteria that they have mentioned in the question, that's it. So we'll be going with the DP1 and DP2. DP1 is nothing but the best chain length that is ending at I, right? So we have to display both best chain length ending at I and which cannot be extended from the envelope. So both, so this one, nothing but the index in simple terms. See here, 1 1 we have got here, right? So dp1 is nothing but the best chain length that is ending at the I. dp2 is nothing but the which cannot be extended from the envelope, right? So which cannot be extended from the envelope. So here envelope 1, right? So basically it cannot be extended from the envelope 1 because width and height are not strictly get greater here, right? So we have dp of 2 1 itself, dp of 2 is 1 itself, right? So max dp here, this is also 1, and dp of 2 is also 1 basically, right? So max dp is 1, we'll choose the corresponding envelope index, nothing but it prints 1 as well, right? So in simple terms, dp of 1 is 1, dp of 2 is also 1. So the final output that we return here is 1 and 1 respectively, right? So 1 and 1 respectively. The output that we got here is 1 1, which is equivalent to the output that they have mentioned for the this one, example 1 within the question, this part, right? So our approach works absolutely correct in this case, right? As we are completely familiar with the approach, let's do one thing, let's quickly discuss the complexities part. So what would be the time complexity here? Basically the time complexity would lead to this one, because of count square plus count into log of count, basically where count has to be less than or equal to n. So this is the average case, right? So we will make use of the filter, then we are sorting, then we are making use of the dp accordingly with the approach that we discussed, right? So in the worst case, this would lead to big of n square rather than this one, right? So we can just consider big of n square. Mostly we'll go with the worst case itself, right? So the time complexity would be big of n square. So what would be the space complexity here? The space complexity would lead to big of n, because we'll be making use of the arrays A, dp array, as well as the LAS variable. So that one you'll get to know when we write the code, right? So overall space complexity would lead to big of n as well, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come here. So first thing is we'll be making use of the fast input and the output. So let me import the input output package here. So I'll just go with java.io. This is fine, and also we'll be making use of the different utilities. So I'll just import the utilities package. So I'll just go with util.star, right? So we have to go with the class. Let me go with public class. So I'll just name every time main itself, so I can just give any name that's relevant to the question, right? So this is fine. So first what we'll be doing, let's make use of the node class to represent the envelope, meaning, so here in this case we have to make use of the width, height, and the original index, right? So accordingly with the approach that we discussed, so I'll just go with static here, class node. So this is nothing but width, I'll just consider w, and we have to consider height as well, I'll just consider h, and also we have to consider original index. So I'll just go with the id for the index. This is fine. Next let me go with the initialization part. So this one will be node int w and h and d, this one id, sorry. Yep, this is fine. Now let's do one thing. We are going with the initialization part or the constructor part, right? So this one will be this one, this dot w equals w. Let's initialize this one, this dot h equals h. This is also fine. This dot id equals id. This is fine, I believe, right? So this is nothing but the constructor part. You have to know this one at any cost, right? So by now, so now next point is, let's go with the recursive helper function, right? So just to print the chain from smallest to the largest envelope, we have discussed this one, right? So let's write this one very quickly. So this one will be static void, I'll just go with print chain. So I'll just go with print chain. So this will be very helpful, we can just make use of it within the main function, right? So this one int k, so this one will be node, this one a, also we need the parameter las as I've said. So this one will be las, and also print writer pw, or let me go with output itself. Mostly I go with out, right? The output. So what's the base case here? If no predecessor, then we have to stop the recursion, right? So this one I can just write it in this way. If k equals, the value of k is -1, then we don't have to return anything. I'll just give the return keyword. This is fine. Now we have to recursively print this one predecessors first, right? So I'll just go with recursion here, this one print chain of let me go with as of k, this one also have to pass a comma las comma this one output. So out I have considered out parameters. So we are just recursively printing the predecessors first. So this is fine, man. Next what we need to do, we have to then print the current envelope's original index. So this one has to be out dot print. So this is fine. This is a of k. This is also fine. Dot id. This one plus this is fine, man. Right. Yep. Let's come outside. Let's go with the main method. Right. This is fine. So within this one, let me give here throws exception. This is fine. So within the main method, I'll just go with buffered reader bw. So this is fine. I'll just go with br instead, buffered reader, right? So this one will be new buffered reader. I'll just go with stream reader. This is fine. Let me give system dot n. Also let me go with print writer here. So this one I'll just go with out, or we have already considered print writer, right? Within the helper method. This is fine, man. Let's go with the string tokenizer. String. I'll just go with tokenizer. This one st equals new string tokenizer. Why this is not showing here? String. Yeah, this is showing here actually. This is fine. Buffered reader dot read line, as we are making use of the buffered reader, right? So this is fine. Now let's go with the number of envelopes, card width and the card height accordingly with the question. So that's what they have given here, right? N w2 and the this one wz and the h, nothing but the width and height. This one n 2 w this one width is 1 and height is 1. So that's what we need to consider here as well. So this one will be int n equals, so these are the integers, right? So they are given in the form of integer dot %. This one st dot next token. This is also fine, man. Yep, this is nothing but the number of envelopes. So let me copy this one entirely. This is fine. Let me paste this one. Let me paste this one again and again. So this one has to be width and this one has to be height. This is also fine, right? So we have went with the number of envelopes, card width and the card height, right? So this is fine. Next what we'll do, let's go with the array to store the envelopes that can contain the card, right? So this one will be node a equals new node of this one n plus 5. This is also fine. And also let's go with the count. Let's initialize this one to the 0, right? So this is fine. Now let's read all the envelopes and filter those that can contain the card. So let me go with a for loop here. This one is int I equals 1, I less than or equal to n. Let's increment the I. So this is fine. So within the for loop, what we'll be doing, let's go with the string tokenizer. Let's create the instance of it. So this one will be new string tokenizer. So this one will be buffered reader dot we have made use of this one, right? So buffered reader dot read line. So we are just reading the envelope line. Also we have to read the envelope width and height as well along with this, right? So w and h. So the same thing. So I'll just copy the same thing and make the necessary changes, whatever the changes that we need basically, right? So I'll just come here. Let me copy paste this one. So instead of wz, I'll just go with the w. Instead of hz, I'll just go with the h here. This one remains same, integer dot %st string tokenizer dot next token. So this is fine. We have successfully went for the envelope width and height. Next step, what we need to do here, so we have to skip if either dimension not strictly greater than the card. So this one I have said during the question, we have to skip if either dimension not strictly greater than the card. So this one I can just write it in this way: if w less than or equal to wz, or height, this one also less than or equal to hz, then we have to skip, right? For skipping, I'll just make use of the continue keyword. This is fine, I believe, right? So if the valid envelope is found, then we have to increment the count. So I'll just increment the count here. So we have to store the envelope with its original index. Somewhere we have to store, right? So I'll just go with array of this one, a of count. So this one, let me assign this one to new. Let me go with node here. This has to be capital N itself. Node. Let me pass width, height along with the index. So this is fine, man. So we are just done with this part. Let me come out of this one entirely, right? So now let's go with a print writer. So here we have made use of the buffer reader only. So we have to go with the print writer for the output as well, right? So this one I'll just go with print writer out equals new, sorry, just give me a second, new print writer. So this one will be new buffered writer and new output stream writer of, let me pass here system dot output. We don't need output stream writer and buffer writer. I believe new print writer of system dot out, I could have considered that one directly, I believe. Let's see. That's fine, no worries. So now let's do one thing. If no envelope can contain the card, then we have to print the single line, this one 0, right? Then we have to flush the output buffer and exit the code, right? So first thing is here, the main thing is if no envelope can contain the card, then we have to print this one 0, right? So then how can we write that? If count, the value of the count is equivalent to 0, then let's go with the out dot print ln this one, let me initialize 0. This is fine. So let's flush the output buffer, nothing but out dot flush here. This is also fine. So we are flushing the output buffer, then we have to exit the code, nothing but I'll just give return here. This is fine. Yep. Now what we need to do, we have to sort the valid envelopes by ascending, then by height ascending. So as per this one approach, this is the filter is the first step that we have done. Now we are going with a this one, what do we call, sort, nothing but the second step, right? So after sorting, we have to make use of the DP, that is the third step. Let's go with the second step for now, nothing but the sorting accordingly with the approach. Whatever we have discussed in the approach, the same thing we are articulating in the form of code, right? So this one is a comma 1, and let me go with a count plus 1 as well. Also new, this one has to be comparator, this one has to be node. This is fine. Did I do anything wrong here? New comparator I have considered. Oh, we are going with a sort, right? So here let's do one thing. Yep, this is fine. I'll just make use of the this one, helper method compare here, public, and so this one will be compare. So let me go with the parameters n1 and n2, right? Node n1 and node n2. So this is fine. Again, so let me write the simple if condition here, because we have to compare the widths and we have to compare the heights as well. First let's compare the widths. So in simple terms, if what we discussed, if node 1 dot width, if it is not equal to node 2 dot width, then we have to return this one. Let's make use of the integer as an integer dot, let me go with the compare. So this one, what we need to pass, node 1 dot width comma node 2 dot width. So this is what we did, as we are just comparing the widths. This is fine. After comparing the widths, if we are having the equal widths, then we have to compare the heights as well. Alright, so I'll just go with return here, integer dot compare. So this is fine. Again, we have to go with the node 1. Instead of the widths, we'll be going with the height. Node 1 dot height only if it is equal widths, right? So just keep this in mind. So this one will be node 2 dot height. So this is also fine, man. Yep, let me go with here this one. Yep, let's do one thing. Let's move on with the next step, further steps. So let's go with the dp array man, right? Or let's make use of the dp basically, right? So dp of I is nothing but the length of the longest valid chain ending exactly at I. We know this one. Let's make use of it first. Let's go with the dp array. So I'll just go with initialization. So new int of, so this one will be count plus 5 for the safer side. I'll just consider count plus 5. I'll just go with a int. So this one will be this has to be array, or else we'll get the error, right? So this is array basically. We have to let me go with a new int of this one. Again, this one will be count plus 5 as well for the safer side. So what is it basically? LAS of this one, LAS I have considered, right? Variable LAS of I is nothing but the index of the predecessor of I in the chain. Just don't forget this one, right? So this is important, not just the initialization part, right? So now we have to initialize the predecessors to 1 basically, right? So minus 1. So this one they have given in the question. When there no predecessor exists, then we have to initial this one give minus 1, right? So let's do the same thing. If for int I equals 1, I less than or equal to count, so this one has to be plus I. This is fine. LS of I, so let me assign this one to the minus 1. This is fine man. Yep. Next step what we'll do, we'll compute the longest strictly increasing chain on both width and height, right? So I'll just go with for here this one, int I equals 1, I less than or equal to count, so plus I. So this is fine. So let's initialize dp of I equals 1 man. This is fine. So we are just going at minimum chain that is ending at I, which has length 1, nothing but length 1 itself, right? So let's go with the for loop again. So this one is for int j equals 1, j less than I. Let me go with plus j. This is also fine, right? So we can extend the chain ending at j by a of I only if both dimension strictly increase, right? So this one this is somewhat right. Let me write this one instead of explaining. As I've said this one in the theory, this one will be a of j dot w, nothing but width, if it is less than a of I dot this one again width. Also we have to consider height as well, right? So and this one a of j dot height, this one less than a of j, sorry, this one has to be, yeah, a of not j, a of I dot height. Also we have to consider this one dp of next element, nothing but j plus 1, right? So dp of j plus 1 this is j whole plus 1 actually. This is fine. If it is greater than dp of I, then what we need to do here, so we have to update the dp for I. In simple terms, we will be assigning dp of I to the dp of j plus 1. So this is fine man. Next we'll store the predecessor index for the reconstruction. So this one will be loss of I. This is equivalent to the j. This is fine. Let me come out of this one entirely. Now what we will do, so we are left with only certain things. This is simple. Basically let's go with the best chain length that has been found. So we have to go with that itself, right? That's what they have asked in the question basically. For that, let me go with the result variable ans here. Let me initialize this one to the 0. Also we'll be considering the flag. We need the flag basically. Let me initialize this one to 0 as well. We need flag because we will be going with the index where best chain ends, right? So that is the reason we'll be needing the flag. So now let's move on with the iteration part. So this one will be int I equals 1, I less than or equal to count. So this one will be I plus plus, or I'll just go with here plus plus I. So this is fine man. Now within the for loop, if the chain ending at I is better, then we have to update its best length. Also we have to record the ending index of it as well. So I can just write it in this way. If iterated value of the dp or dp of I, if it is greater than answer, then we have to update its best length. In the sense, let me assign the answer variable to the dp of I. and we have to record its sending index in the sense, let me assign the flag to the I. This is fine, I believe, right? Simple. Let me come out of this one entirely. We are left with only the output part, right? So we have to print the maximum chain size. Actually, maximum chain size itself we have to print. Basically, that's what they have asked in the question as well. For that, I can just make use of out dot basically println out dot println. We are just making use of the print writer right here. The print writer variable is out, out is nothing but output. So let me pass answer. We have passed the answer variable ans result variable, right? So this is fine. Next, we have to print the chain that is starting from the smallest envelope, right? So this is recursive basically. So for the recursive helper method, we can make use of this one helper method. We have already written print chain, this one, right? The first helper method. So let me come here. So see here in the output we have two lines, right? So this one also, right? So this is the longest chain that maximum this one maximum chain size, and also we have to print the chain that is starting from the smallest envelope, right? So this one, the second line. So now we are printing the second line basically, right? So this is printing the second chain basically. In the exam for the example 1 we got 1 and 1. The maximum chain size that we got is 1, and also the chain starting from the smallest envelope, that also we got 1, right? So here I'll just go with print chain. Let me pass flag a, also las, also out. This is fine, right? So we are left with only certain things. We have to move to the next line, right? So here see, we are not printing on the same line. We have to move to the next line 1, and then next line 1. So we have to move to the next line. This will be out dot println. This is fine. Yep. So this is the new line, and also finally we have to flush the output. So this one is out dot flush. This is also fine, right? So this is it for the code basically. Somewhere I have done something wrong, man. I don't know what wrong I have done, what thing I have done, but something I have done wrong. I don't know where. I don't know where I have done wrong, but I have done something wrong. Just give me. So let's see what are the things that we have done wrong here. So first thing here, so let me come to the main method here. So this one, see, %i has to be capital here, right? So this is fine. Just 1 second. This one has to be I as well. And finally let me go with this one as well. This one has to be I capital as well, right? So this is fine. Next, what I have done here is, so basically I'm going with node this one of a equals new node of n+5 I'm giving here. So this one has to be capital N basically, right? So this will give us node is undefined because case sensitive, right? So this is case sensitive basically. I have to give the capital N basically, right? Or else we'll get the error. This is fine, man. Now again let me come here. Oh, again I have given here small I %. So this one has to be capital I basically. This is fine now. I don't know if any other error exists basically. Let me come here. So we are calling the print this one print chain this one inside the node class, right? So basically let's do one thing. I'll just go with node dot this one print chain. So let's do this. Let's see whether this works. So this is the reason. Let's see first. So I'll just copy this one entirely. So let's copy this one. Let's check first. Then we can just go with this one, right? So this is fine. So we are getting the wrong output, right? So main method is found in the class main. Just give me a second here. So let's do one thing here. So I have given the extra this one, right, bracket here. So let me cut this one. So let me close this one node class, right? So this one, let me close it here itself, right? So now this has to work. So bracket was the problem, I believe, right? Yeah, we are getting the output 1 1, right? So which is absolutely correct. So do we have another input? Yeah, we have here the output that we need to get here is 3 1 3 2, right? Let's check the same here. So we are getting 3 1 3 2. So this was the problem actually. Note this one, I'm closing here, I have closed here. So now this works absolutely correct, right? So this was the main problem, bracket. And some of them, this one we have already cleared. Basically this one, typos, right? So %, has to be I has to be capital, basically. That's what and one more thing here, it has to be node, or else it will give us this one, node not defined, basically, right? So this is fine. Now before submitting the code, I just want to copy paste the signature starter template. Just give me a so I'll just come here, let me paste it over here. So this is fine. Now let me copy the entire code. I'll just come here, let me hit the submit button. Yep, we have already selected 4D, this one problem D, right? So let me hit the submit button. I hope this works for all the test cases, man. Let's see. So we have made use of the pure DP for to solve this particular problem, basically. I'm not gonna lie, right? So this is absolutely classic DP. This is fine. Yeah, you can clearly see here in the toast it is showing accepted, right? So we have the verdict accepted here, right? So we have the verdict accepted here. This is fine. Now yep, whatever the I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.